really excited to be here. But before getting started, I'm just going to put this slide here. So basically, with this slide, the QR code or the link you see in there, you can get the slides live, so you can go back and check whatever code examples, or if you want to steal my fancy unicorn in there, you can do that. And while you take the time to go there, I'm going to just say thank you, everybody, for being here. Thank you to the organizer for allowing me to be here with you. And yeah, let's get this one started. So you are probably wondering, who is this guy here in front of you? Hello, everyone. I am Luciano. As you can probably imagine by my funny accent, I am Italian, but living in Dublin, where I work for Vectra. So Vectra is a very interesting company. Vectra works in the intersection of security and machine learning, and it builds a number of products for basically real-time threat detection and then investigation of this kind of detection. So if you're really curious about this stuff, come to talk to me after the talk, and I'll be really happy to tell you more. Other three things that I'm really proud of, some side projects I've been working in the last 2 years together with amazing people. The first one is a book on Node.JS and design patterns with Mario Casciaro. Then there is Full Stack Bulletin, which is a newsletter for people that want to learn full stack, or they are already full stack developers and they want to keep updated with the latest changes. And then there is Serverless Lab, which is basically a set of open source training courses or training material that allows you to get started with serverless on AWS. So I hope you will have a look at these projects and give me a feedback, because I'm really excited to know your opinion on them. But let's get this started. So today I'm going to talk about JWT and many things related to that, with some Node.js fancy stuff in between. But all of that I'm going to talk today is based on prior work. And there are 2 articles that I published on Rising Stack. So if you see that something is missing or that I'm not giving too much details today, you can go and read the articles. Probably you will find all the missing bits in there. So okay, today we are going to see what's JWT, how it works. Then we are going to try to figure out, okay, how can we reverse engineer a JWT token or build a new JWT token from scratch. And then finally, we are going to see the weaknesses of JWT and how you can actually brute force one JWT token. So let's get started with some definition. JWT token, by the book, means JSON Web Token, and it's a compat URL-safe means of representing claims to be transferred between 2 parties. The claims in a JWT are encoded as a JSON object, and yeah, this is boring, right? Can I stop here? Okay, let's try another approach. This is a JWT token. Is it more helpful? Well, probably not, but let's see. Let's try to make it simpler. I'm going to give you my definition. So JWT is a URL-safe, stateless protocol for transferring claims. Okay, you're probably asking, URL-safe, stateless, claims. I'm going to try to explain better. So basically, URL-safe, it's a very simple concept. It basically means that the token itself is just a string, and you can embed this string safely into a URL, which basically means that it doesn't contain any character that can be ambiguous for a URL, like an equal sign, a slash, or a question mark. So basically, as you can see in the example here, you can put the token as part of a query string parameter, for example, and you can be sure that it's not going to break your URL, so you don't have to do any special encoding or decoding. Stateless is a very interesting concept, and probably is the main reason why you should be interested in JWT tokens. And basically means that when you have a token, you can verify if it is valid without having to check like a database or a third-party service. And we will see later how this can work. But sometimes people refer to this property as being self-contained. So they say JWT tokens are self-contained. Then what is a claim? Well, in general, it's some information that we are trying to transfer between systems. And it can be basically anything. Most commonly is identity. Like, for example, if you are creating a token, a JWT token to create a login session, the token itself will contain some information about the identity, like, for example, the user ID. Then you might have information that will tell you, okay, this token is an API key, or maybe you can use the token to define ownership. For example, somebody purchased a ticket for a concert, and you can embed in the token the information about the owner of the ticket and the kind of concert that we are talking about. But when we talk about claims, it can also be validity constraint for the token. For example, You shouldn't use this token before a certain timestamp or after this timestamp, or maybe you should use this token only for a specific audience, for example, a given website and not another website. Or issuer identity, so this token was generated by website X and not by something else. So another thing when we talk about claims is details about how the token is built, so the type of token and the algorithm. But in general, a claim is all the bits of information that you can find inside the token. We will see this better in a second. So let's go back here. This is still very cryptic, all right? But if you look carefully, there are 2 dots in there, and those 2 dots allows you to divide the token in 3 parts. So we are going to try to understand now what are those 3 different parts. So the first part is called the header, the second part is called the payload, and the third part is called signature. Header and payload are base64 URL encoded. Base64, you are probably familiar with it. And base64 URL is a slight variation of it, where basically all the characters that can be sensible in a URL, like the equal sign, are replaced with alternatives that are safe to be used inside a URL. So if you ever use base64, you know it's just a simple algorithm that allows you to encode and decode bytes into strings. And base64 URL is just the same. You can encode and decode, and it's going to apply this extra transformation to make it safer for URLs. So once you know that, you can start to think, OK, I show you this header, and this is base64 URL, so let's decode it. And you will see that a JSON string appears. Same for the payload. This is just a base64 URL string. Let's decode it. And again, we have a JSON string. So basically, a token contains just JSON data, right? So let's start with the header. Let's try to understand what is the data inside this JSON string. So the header is pretty standard. Almost all the time you will see the header to be exactly the string. And there are 2 fields. The first one, ALG, which stands for the kind of algorithm, and TYP, which is the type, and it's always JWT. Algorithm is very interesting. You have many, many variations. The 2 most common are HS256, which is the one we are going to spend most of the time today. But there is another one called RS256. So the first one allows you to create a signature using just a secret, so asynchronous kind of signature. The second one allows you to create signature using public and private keys. So we are going to see more details later on. For now, let's just understand that you can use different algorithms. There is another very infamous algorithm that is called Node. And the reason why it's infamous is because a few years back it led to different security issues. I'm not going to tell you the story because it's very long, but if you click into infamous later on, you can read an article that will tell you all the details. For now, you just need to know that you shouldn't use this Node. I think it's actually disabled in many libraries. So payload, we saw it before. Here in this example, it's just message hello people, but can literally be anything. So you can put in the payload whatever you want. And I'm going to give you a better example. So in general, in a payload, you will put what are called by the protocol registered or standard claims, and are things that can define, for example, the issuer. In this case, out0 is the service that is creating the token, or the subject, so the specific person or system for which you are creating a token. And then you have audience, expiration time, done use before, generated at a given timestamp. So these are all registered tokens, and if you read the RFC, you will find a lot of them. So in general, a JWT token, if you use the standard claims, will look something like this. So far we saw that a token is just a string that somehow encodes metadata. So why do we say that JWT are safe, or why should we use to transfer claims safely? And the reason because it's safe is because it also contains a signature. And a signature, what is it? Again, it's just a string. Again, it's just base64 URL encoded. But it's a cryptographic signature. So if you never experienced cryptographic signature, basically it's an algorithm that allows you to say that a given content is somehow authentic. It has not been forged by anybody, and it's signed by a specific authority. So in this case, the way the signature is calculated in JWT is basically just an MAC SHA 256 hashing. which you will have libraries in any language to calculate the hashing. And basically, the hashing is done on the header and the payload combined together, separated by a dot, and then we apply a secret string. So basically, the ingredients we need to calculate the signature are header, payload, and secret. Once we have them, it's very easy with this function to just obtain the signature. So the tricky thing here is that if you know the secret, you can verify the authenticity of the token. So basically, you are getting a token. This token is telling you, Luciano purchased a ticket for a concert. And then there is a signature. If you know the secret for that signature, you can tell if that token is authentic or not. So now I'm going to show you how to create a token from scratch. I hope you can read this one. So basically, we reverse engineered a token so far. Now we are trying to build a new one from scratch. We know that there are three parts, an header, a payload, and a content. And they are all, the header and the payload, they are just JSON string with base 64 URL, as you can see here. So basically, we have header, which is just algorithm and type, and it produces this part of the token. Then we have a payload, so we are creating this message, hello New York, we stringified it, and then we base 64 URL encode it, and we get this other part of the token. So at this point, we have the content, which is just the combination of header, a dot, and the payload, which is basically this string here. And in this string, so with this string, we can actually calculate the signature. And we are decided that we want to use a secret called we are web rebels. So this can be any string, and you have to keep it secret, because this one allows you to create and validate tokens. So this will be probably only in your server, in your backend logic. And basically, we can apply in Node.js this crypto library that will calculate the HMAC. And then this way, we generate the base 64 signature for this secret and this string. And finally, once we have the signature, let me scroll a little bit. We can just combine the content with the signature, and we finally have our JWT token. OK? So at this stage, you are probably wondering, OK, but if I have a token, is there any way that I can use to debug this token and see what's really inside? And one website that is very helpful for this is called JWT.io. It's maintained by OutZero. And it's like a debugger for JWT tokens. So you can get any JWT token from any website that you're using, and you can just paste it in here, and you can see what's the content. So here we are seeing hello New York, and you can actually even play with it. So I can change things, and I can say, for example, hello people of New York. And you see here it's changing the JWT token. So this is actually a tool that you can use to troubleshoot or trying to understand what is the information inside a token. And you can even use it to verify a signature, OK? So let's go back to the slides. I showed you JWT.io, so it's this playground that you can use to debug JWT tokens. But now I'm going to give you an example of when it's useful to use JWT token, so you can have a more practical idea on when and how to use a JWT token. So the most classic example is session authentication, and I'm going to show you first how do we do it generally without JWT, so with a standard cookie. So when we do it just with a cookie string, you have three entities, a browser, a server, and a session database. So the first message is probably somebody trying to log in. So there is a form, there is a post message where we are sending username and password. So from the browser, we are sending this data to the server. The server is going to do something. It's going to just read the data and connect to a database to figure out if this information is correct. And if it is, so if this is my real username and my password, it needs to create a session for me. So to do that, it's going to generate a new session. So basically, it's going to create a random string, in this case, this random string you see there, that is the ID of the session, and then it's associated this information with the current username. This is stored into a session database. So at that point, the server will send back to the browser a cookie saying, OK, you are authenticated, and this is your session ID. Next time you get back to me, remember to send me your session ID, so I will know that you are already authenticated. And that's what's happening when the browser will ask for the profile page. So the cookie with the session ID will be attached, and the server will receive this information. At this point, the server just knows the session ID, so to know which user is associated to the session ID, it will need to interrogate the session database, which will tell you, okay, this session with this ID is still valid, and the user is Luciano. So there is a record that gets back to the server, and the server can say, okay, now I can render a page for Luciano. This is, I think, a pretty simple flow, and probably everyone here had to deal with something like this at any point in time. But let's see how it looks like if you decide to use JWT instead of the classic session storage with a random string. So with this approach, we just need to worry about two parties, the browser and the server. So again, the browser will send the login information. The server will verify if this information is correct. And this time, instead of creating a random string to identify a session, it will create a JWT token. So inside the token, it will say, OK, I'm going to write that the user that this token is generated for is Luciano. And then it's going to add a signature to this token so that it will be able to recognize later on that this token is valid and has not been forged by some other system. So this time, the response is sent back with not just a random string, but the entire token. And the token is going to tell the subject of this token is Luciano. I'm not specifying here a cookie because there are different practices. It might even be a cookie, but some people prefer to do it with local storage. I'm not going to go in much detail about this, but if somebody's curious about what are the different strategies, we can talk later after this talk about how to make this secure and what are the trade-offs you can make. So at this point, the browser will store this information. Let's say it's a cookie for now. And then it's going to send it back to the server to request the profile page. So at this point, the server received the token. It doesn't need to go into a session database because the server knows how to verify the signature. And if the signature is correct, it can tell, OK, I can generate a page for Luciano because the information Luciano is already inside the token. It's not in a third-party database. So it can generate immediately the page, hello, Luciano. Notice that that secret is known only to the server. So it's never shared with the browser or any other third parties. So the server is the one that can create and can verify JWT tokens. OK, let's compare what are the trade-offs here. When we do the cookie session implementation, we need a database to store the session data. The database is queried every single request to make sure that the session is still valid and to get the information about the user. And then there is no extra data attached into the token, so it's just a random string. And of course, with this thing in mind, you can invalidate session at any moment in time. So you just go to the database and say, next time you receive the string, consider that this is invalid, so you have to make a login again. With JWT, you don't need a session database, so ideally it's much faster. The session data is embedded in the token. So for every request, the server just needs to verify the signature, and then it can take for granted that the data that's in the token is valid. But you have to be careful, because all the data that's in there, it's something, as I showed you before with JWT.io, that anybody can read. So don't store passwords in there or any sensible information. Even user emails, sometimes you don't want to store them because there are different ways that you can steal the token and read this information. So another problem is that session can be easily invalidated because unless you build your own blacklisting, which is kind of defeating the purpose of JWT tokens, you have to wait for the token to expire. There is no way you can invalidate it simply without building another layer of infrastructure. So these are the trade-offs, of course, that you can make with JWT as opposed to cookies. But there are other use cases. Another one that is very interesting, and this actually it's much, much easier to implement. I don't know if you ever had to build your own password reset. It's one of the most painful things, even if it looks simple. And with JWT token, you can make it much, much easier. I'm not going to go in details, but again, there is an article that will show you a demo of how to build that, if you're curious. So, OK, JWT looks great, but there are pitfalls. And the first pitfall, you probably already understood this, is that all the data is public. So again, if you manage to get the token, then you can read everything inside of it. So if somebody is getting your laptop and you are logged in a system where your JWT token is still in your browser, if there is your password inside of it, it's not safe. So be careful that everything you put in the token can be read as soon as you have the token. And then there is no token database, so you can start to think about evil things to do. So if I can manage to create a token myself, well, the server will not know how to tell that token is authentic or not. It's going to take for granted that if the signature is valid, then the token has been generated by the server, so it's going to consider valid everything inside the token. So I'm going to show you now a little demo app, which is built with Fastify. So if you never heard about this amazing Node.JS framework, have a look at it. And the little demo is called Merlin Online Spellbook. So basically, if you want to manage your magic spells online, you can use this website. But this website will require you to log in. And in this case, I'm going to log in with my amazing username and my super secret password. And now I have a session. But my session is telling me, OK, you are Luciano, I know that, but you are just a normal user. And with this role, you cannot do any spell. But now I'm looking here a little bit more carefully, and I see here that there is something weird that represents probably a session. It looks like a JWT token. So I'm going to go to jwt.io. I'm going to open a new tab. Oh, I don't have internet, so let's do it here. Let's put a random secret for now. And I'm going to paste the token here, and it's going to tell me, OK, this is the information inside the token. So I can see that the subject is Luciano, so it's recognizing the user. The role is just user. And then this is just to say, OK, this token was generated at a given moment in time. So now here I'm starting to think, OK, this website is not allowing me to do anything because I'm just a user. So what happens if I put here admin? I'm getting here a new token. Let's see what happens if I try this. So I just have to replace this one. And of course, it doesn't work. Can you tell me why? Yeah, of course. So here I have just a secret, which is just XXXX. And it's probably not the same secret that the server is using. So when I'm sending this request here, the server is verifying the signature, and the signature doesn't match the expectation of the server. So basically, the server is able to tell, this is not a valid token, so I'm going to invalidate your session, and you have to log in again. Let's go back to the slides. So OK, now what happens? So we know that the secret here is the magic ingredient, right? But what happens if we want to guess the secret? How hard can it be, right? And we can actually start to think, since we are Node.js developers and we like to do crazy things, yeah, let's build a distributed JWT token cracker. So basically, let's try to brute force the secret. And before actually going into the details of implementing this, I'm going to show you how it really works. So I have an implementation here. So since this is distributed, of course, we have two components, a server and a client. The server, I'm going to show you the help. The server basically accepts a token. And you can also specify an alphabet if you want to limit the scope of your brute force attack. But we're going to see this in a moment. And the client, you just run it, and it's going to try to connect to the server. So the server will coordinate the different brute force attack, and the client will just do the heavy work of trying different secrets on the token. So now what I want to do is to start the JWT server here. Sorry, JWT cracker server over an alphabet that is limited. I'm going to cheat a little bit because otherwise this will take too long. And I want to do this over the first token that we got during our login, which I think is this one. So now the server is started, is listening on a port, and is waiting for client to be connected. Now here in my machine, I will start 4 clients. Of course, this is distributed, so if I will tell you somebody here my IP address, you can help me to crack this, but we're not going to do that for time reasons. OK, so this is starting to do its work. You can see that the 4 clients are connected, and they are starting to try strings. I'm going to leave this one running in the background, and we are going to get later to this. Hopefully, we will be lucky, and before the end of this presentation, it will have done the job of cracking the token. But let's try to understand better how this works and how can you implement this yourself, what I'm showing you here. So again, what's the idea? We got a valid token from our first login attempt, and we are trying to guess a secret. And how does it work, this guessing exercise? So basically, we know what's the algorithm to validate a JWT token. So we can try any possible secret over an alphabet until we figure out that we get the same signature that it's in the token that we know is valid. So that's actually what the algorithm is doing in a distributed way. It's trying every single string over an alphabet until it can figure out, okay, this string is actually matching the signature that we expect. So this must be the secret used by the system. And when we find the secret, that's the most interesting part, then we can create our own token. So we can actually pretend we are the server, and we can put any information inside of it. So the magic weapons we are going to use for building this distributed system is Node.JS, because this is a JavaScript conference, ZeroMQ, and JSON Web Token module. If you've never heard of ZeroMQ, it's an open source embeddable network library. It's written in C++, I think, and also a concurrency framework. But basically, the reason why I'm using it here is that allows you to have networking patterns in a way that it's very easy to say, okay, I want a communication channel between the server and my clients, and the channel needs to respect some rules. We will see this better in a moment. But before doing that, let's try to understand the brute force problem. And the interesting property of this problem is that you virtually have an infinite solution space. So just imagine you have to try all the strings over a given alphabet, right? So in this case, we have an alphabet that is A, B, C, and 1. So you can see there. And basically, if you start to create all the possible strings over this alphabet, you will realize, okay, after I do empty string A, B, C, 1, then I start to combine things. So AA, AB, AC, and so on. And you immediately realize that you can build infinitely long strings. So you don't know how long this string is going to be. It can be ideally infinitely long. So maybe you will never find the solution. So that's why this is a very hard problem to solve. And if we want to start to use some mathematical concept that can help us while building this prototype, we can talk about a bijection or a bidirectional relationship between the set of integers and the set of strings over an alphabet. Another example here, we decided to use an alphabet with just A and B. And if we create this ordering, we can say, OK, we can associate the number 0 to the empty string, then the number 1 to A, number 2 to B, and then we start to combine the letters in order. And this basically gives us a very nice property for which a single integer can represent a string over our alphabet space. So I told already this is a distributed system. We have a server and we have a client. What is the role of the server? The server is just going to initialize the environment to crack a given JWT token and with an alphabet that we decide. And then it's going to coordinate the brute force attack with all the available clients. The client is is the entity that knows how to do the heavy work. So it's going to know how to actually test a secret against a token, and basically constantly receive a range of strings to try from the server, and it will try to do its job. And it's going to tell the server back, OK, I didn't find anything, so give me something else to do. Or I finally found the solution, so you can stop everything, and you have your secret there. So I told you that we used ZeroMQ, and ZeroMQ give us very nice networking patterns that we can use. And we are going to use here two different patterns. The first one is called router dealer, and it's a single channel of communication between the server and one client. And it's basically implementing the request response pattern. So the client will initialize a connection to the server, sending a message, OK, I want to connect. Then the server is going to respond back. And then this communication is always request and response. So there are never many messages in between. It's always waiting for a response from the other party before sending another request. So this is very convenient to create an individual channel between two different entities. But we have another pattern here, which is the publish subscribe, that we use for the termination signal. And this is basically like a messaging bus on which the server can say, OK, somebody found the secret, so let's stop computing things. So if you have 10,000 clients, with just one message, the server can tell everybody to stop calculating the possible solution. So let's try now to understand how can we build this server. So how can we represent the state of the server? And the first idea that we can have is that we can slice this solution space over an alphabet into chunks, because of course we want to have as many clients as possible, and we want to split the work across different clients without having different clients to try the same string. So ideally what we can do, we can decide a batch size. In this example, the batch size is 3, and we can say, okay, from 0 to infinite, the first batch is going to be 0 to 2, the second batch is going to be 3 to 6, the other batch is going to be 6 to 9, and of course we can do this forever until we find a solution. So how can we represent again the internal state in a more practical way? We can create two records in the server memory. The first record is just an integer that is called cursor, and the second one is a set of clients. So initially we don't have any client connected, and we are starting from the first possible string. So of course the cursor is set to 0. At some point we will have one client connecting, so we register the client in the list of clients, and we can start to dispatch the first job to do to this client. So we give it the first batch. We are telling him, okay, start to search for a solution from 0 to 2. Then after a while, we have 2 other clients joining, and then they get the successive batches, so from 3 to 5 and from 6 to 8. At some point, one of these clients is going to finish his job without finding a solution, so it's going to tell the server, please give me another piece of work to do. And it's going to get from 9 to 11. And you notice, probably notice already, that the cursor is moving forward, and it's always pointing to the first available batch after the ones that have been already assigned. So how can we implement this logic? It's actually very simple. So basically the initial state is written here in the main 2 lines. So cursor is 0, and then we have a map of clients which is initially empty. Then we have 2 functions. One is called assign_next_batch, and the other one is called add_client. So if you have to do this programmatically, you will just call add_client bypassing a channel, where channel is a ZeroMQ communication channel. And this logic here is just attaching it's just creating the client description, saying, okay, this client will have an ID that is internal to ZeroMQ, a communication channel, and then I'm going to store also the join timestamp. And then I'm going to say, okay, since this client is new, assign it the next available batch, and then store it in the client map. In the assign_next_batch, very simple logic, we are saying the new batch is going to start from the current cursor plus the batch size, and then it's basically just an array from and to, so 2 elements in an array, and this message is at some point sent to the actual client. So this is all the server logic. So just to visualize this one better, at some point a client is joining the server, so it's sending the join message. The server is responding, saying, okay, this is the token we are trying to crack. This is the alphabet that we are using to generate strings, and this is the first batch you can start to work on. Then the client will try to do his work on this batch, and at some point says, okay, there is no solution here, give me another batch. So next means I couldn't find anything, give me the next available batch. And again, there is a batch that is going from the server to the client. This flow 3 and 4 can go on forever until somebody will find the secret, so there is a success message, and from there everything is stopped. How do we implement this logic in the server and the client? Again, with ZeroMQ it's very simple. You can see that every message has a type here, and based on the type we have here a switch case where we say, okay, if the message is join, then I know I have to send back the current batch, the alphabet, and the token. If the message is next, I just have to send back the first available batch. And if the message is success, I have to send in the signal socket the termination message saying somebody else found the secret, so everybody can stop his work. In the client, we have a very similar logic. Again, we have a message type, and the kind of messages that are received by the client are start and batch. Start is the first message when the client connects, and then batch is just when we receive the next batch. But how do a chunk is actually processed? Because we are saying right now that we just send numbers. So for example, from 3 to 6. How does that relate to actual strings over an alphabet? And you can see here that 3 is associated to AA, 4 is associated to AB, and 5, BA, and so on. So basically, the client will know the alphabet because the first time it connected to the server got the alphabet back. And then based on 3 and 6, is going to use that relationship that I used before to figure it out. OK, 3 is actually AA, and 6 is actually BB. So I'm going to try all the strings in between. And if one of them is the secret, I can stop. Otherwise, I have to ask for another batch. And the logic to do that is implemented here. But there is a piece that is a little bit hidden, which is this index string variation. This is a library I wrote. And here I'm just importing it. If you're curious, you can go and read the code. But basically, this is the one that is implementing the logic, how to go from a number to a string over a given alphabet. And everything else here is just a for loop that goes in the available batch range and tries every single attempt. So it's going to run JWT verify. It's going to ignore expiration and not before, because this library by default is going to tell you that a token is not valid if it's expired. But we want to crack even expired tokens. So basically it's saying, OK, verify this token. And if this doesn't throw an exception, it means that we found the secret. Otherwise, we are just catching and ignoring the exception and trying the next element in the array. So let's go back to our demo. Let's see if we were lucky. Oh, yes, we found our password. And the password is pizza. What can you expect by an Italian in New York? So just to recap here, you can see that the server was listening for connection. Then there were 4 clients joining, and the clients got some stuff to do. At some point, one client started to request for the next batch, and they started to request for other batches until one client actually found was the secret there. And then the termination message was propagated to all the clients. So we can see here that this one received the exit signal. This one is the actual one that found the password, so the second process, and the other one received just an exit signal as well. So now I know that the secret is pizza, right? Actually, here I have the token. So I can go back to our demo application. I'm going to log in again. I'm going to go here. And if I go back here, so I'm going to take this token now that I know the secret. I'm going to paste it here. And now I know that I can use here pizza. OK? Now it's telling me that it's a weak secret. That's a great thing to know. But here I can just say user admin, right? That's what we wanted to do all the time. Now we expect this token to be valid. Yes, so we are Luciano. We are an admin. And as an admin, we have the most powerful spell. Let's try it. Thank you. OK, so let's try to recap. So the first thing you are probably asking yourself, is JWT safe to use? And I mean, of course it is. Many big players in the industry are using it heavily, like OutZero, Cognito AWS, OpenID Connect, and there are many, many more that are using it. So what is the trick? You have to use it wisely. And wisely means that you have to use a strong password, a strong secret, which most of the time means long enough to be safe. Or even better, if you have an application that is very security concerned, you can use the other algorithm where you are using a public and private key pair, which is much, much harder to crack. And also will have other properties for which you can allow other systems to verify the token without having them to know the actual secret, because you will only have to share the public key and the private key is only left to the authority that is generating the token. OK, then there is this other question that you might have. What if I create short-lived tokens? So what if my token expires in 3 minutes? I showed you I cracked the token in like 5 minutes, 10 minutes. So what if I just create tokens that last 3 minutes? And of course, this is not a solution because JWT is stateless. So even if you have a token that is expired, this token was valid at some point in time. So the signature is still there, and the secret used is still something you can try to brute force. So even if I get a token that is 1 year old, I can still use that valid token to figure it out what is the secret. So be careful of that. And of course, the expiry time is embedded in the token itself. So once I know the secret, I can change that expiry time when I generate a new token. So that's the trick. The short expiry time doesn't help you to make it safer. So the next question will be, should I be worried about brute force? Well, kind of. Probably not. I'm going to just give you some benchmark I ran. So basically, with a secret that is 5 characters long, like pizza, the one I used there, with 4 machines on AWS, you can crack it in more or less 2 minutes. But if you just start to add a character, it takes 1 hour and 32 minutes. Then you add another character, and it takes 3 days and 18 hours, so almost 4 days. I am running one test on 8 characters since like 6 days or something like that, and it's still running. And it's probably going to take a month or more. And the other one on 9 characters, which is like 5.5 trillion combinations, I'm not even trying that. And I'm going to give you another example, which is basically, what if you use a 64-character secret? This is the number of combinations. This is the number of strings. I cannot read that, so I'm going to just say 3.6 gazillions of attempts. So good luck with that. It's probably going to take centuries before you can crack that, unless you have millions of machines you can use. So just to close it off, JWT is cool, it's stateless, allows you to transfer claims. Just choose the right algorithm. If you choose the synchronous algorithm, just be sure that you are keeping your secret safe and make it long enough so that it's secure. Don't disclose sensitive information in the payload, so no passwords, no emails, no credit card numbers. And then don't be worried about brute force if you understand that it's not feasible unless you have a very, very weak secret, or you have somebody against you that has a massive compute power, like millions of machines. So that's basically it. Thank you very much.
So we have time for one question, maybe two, if we're quick. Does anybody have any questions? I can run with the mic.
I have a quick question. Can you use JWT to manage sessions? So now with extra session, the session gets, let's say you have it set to like 20 minutes, it gets increased automatically. If you use JWT, can you do the same thing where every time you make a request, let's say to the backend or something like that, the session gets increased automatically by itself, or is there something else you have to do that?
Yeah, that's a good question. So let me rephrase it to make sure I got it right. So you are saying you create this token the first time, and then after every request, you will generate back another token where the expiry time has been increased by 20 minutes, let's say, right? And this is probably something that will happen in many, I don't know, banking application where you have 5 minutes tokens, so you want, if you are using the system, to be upgraded. Of course, you can do that. And basically, the idea is that you will regenerate the token and send it back for every request. So let's say it's a cookie. You will receive the cookie in the server, and then as a response, you will attach the new cookie with the new session token. So it's something you can actually do. It's not going to make it safer unless you change the secret every single time. So that's not easy to do, because if you change the secret every single time, then you have to track which secret is used by every token, if that's your concern.
So it's going to be a new token every time?
If you want to increase the expiry date, yes.
Regarding what you just said, can't you, since you can read the public part, why can't you have a secret that depends on that? So every time, if you increase the session time, you will modify your secret in some predictable way. Why couldn't you do that?
Yeah, that's actually a good idea. So let me rephrase again. So basically, you're saying maybe as a claim you will say secret number 1. And then the second time you will have secret number 2, just as an ID for the secret. So the server will know which secret was used and can easily verify. So that's something you can do. I think it's a smart idea. But there is one trade-off with JWT that is very common, where basically you want it to be as much stateless as possible, because that gives you the advantage of being very fast in generating the token itself and then responding. So every time you add something on top of JWT, like state logic, you will have to deal with an extra layer. Like I've seen other people using like an encryption layer over the JWT. So the JWT itself is encrypted, so you cannot even read the claims so easily. But that's, again, something you have to manage on top of JWT. So all of these are valid solutions. It's just the trade-offs you want to make based on your application, if you want to have one or more extra layers on top of it.
That's it. That's all we have time for. Thank you very much. Thanks again.
Thank you.